Okay, example 1, evaluate, and this is read as such. The integral of 4 plus 7x from negative 3 to 4 with respect to x. I'll say it again. Evaluate the integral of 4 plus 7x from negative 3 to 4 with respect to x. That's how you read it. Okay. Or you can just say squiggly thing 4 plus 7x dx. All right, if you're trying to talk to somebody else about it, you know, just to identify. But the official mathematical language involved there, that's an integral symbol. And there's a function. There's a variable in the function that matters. Okay, so if there were several variables, let's say it was 4a plus 7x dx, a is going to be a number, like a number, x is going to be a variable. So the dx tells you what variable is there. And these numbers, negative 3 and 4, represent an interval. So relating it to what we did in chapter 5.1, then we're going to find the area under y equals 4 plus 7x on the interval negative 3 to 4, and I want to use 20 rectangles. Okay. The purpose of this chapter is to come up with a way to evaluate that kind of expression anytime with them, no matter how ugly they make it. Okay, I can give you a calculus 4 integral. You can use the numerical techniques we're doing today. There's no way in the world you'd be able to do a calculus 4 integral. Those things are mean and nasty. All right, the ones we're going to have aren't very mean and nasty. They're going to be pretty simple. But as you continue on in calculus, if you get to an integral you can't do, which happens, some of those integrals are really, really hard to do what you need to do. This technique will work to get you at least a close approximation of the answer. The more rectangles you use, the more accurate it is. So let's say you're doing a calculus test and you need to get a correct enough answer. 20 rectangles is probably good enough. Let's say you're building a bridge, you want to make sure it doesn't collapse. Maybe you go about 2,000 rectangles if you want to use an approximating technique. Or ask one of your buddies to evaluate the interval for you, because that will get you the exact answer. But using 20 rectangles, I want to use the midpoint method every time. So keep that in mind. That's what the homework is tonight. Any problem that looks like that, it's a midpoint method problem. This is the function, that's the interval, and we're going to use 20 rectangles. All right, so first off, delta x. The distance from negative 3 to 4 is 7. Divide that by 20, we get 0.35. I like using 20 rectangles because you get a nice terminating decimal almost every time. There had to be something weird about the interval for it not to be. Usually the intervals are nice, like 2 or 6 or 7 or 5. Any integer divided by 20 is going to be point something, just a couple decimal places at most. All right, our starting point is negative 3, right? That's where our interval begins. But we're doing the midpoint method, so we're going to do half of the delta x. That's going to be my first x. All right, so I'm using Excel, so I'm going to go over here to Excel, and in the first x box, I'm going to type in, I could figure out what negative 3 plus half of 0.35 is, but if I just put equals, hit the equal sign first, and then I type in negative 3 plus 0.5 times 0.35. Right. That'll evaluate it for me. So negative 3 is the beginning of the interval. I want to go halfway into the first rectangle. Each rectangle is 0.35 wide, so half of that is how far into the interval I want to go. I hit enter, and it evaluates it for me. All right. My equation is 4 plus 7x. So in the y column, I put equals 4 plus 7 times, and then I click on the A2, the first x value. So 4 plus 7 times that x. I hit enter. That evaluates it for me. Delta x is 0.35. So I just type in 0.35. And the area is always going to equal this times this. So it's always the y, which is the height of the rectangle, times dx, the width of the rectangle. So b2 times c2, enter. And just like that, I've got the area of the first rectangle. Notice it's negative. That's all right. Okay? So we're evaluating this integral. If we get negative numbers are fine. A negative number just means that the graph is partially below the x-axis. And if you get a negative area altogether, the answer is negative. That means the more area was underneath the x-axis than above the x-axis. That's perfectly fine. All right. Then, the only other real math I have to do here to create anything happening on this is I need to make sure this x gets filled all the way down. I want to keep adding 0.35 to the previous number. So the formula I type in is equals, and I click on the previous number, and then I add 0.35. So it looks like this, equals, always hit the equal sign before you put a formula in. I'm going to click on the number I want to evaluate and add 0.35 to. That gets me my next x. So this tells me, this formula here says, go to the cell above and add 0.35. And if I want to continue doing that, I just notice how the cursor is like a big plus sign, right? It changes to a moving sign. If I get over here in the corner, it changes to like this thin plus sign. Click and drag down. It just fills that formula down for us. And I want you to see what the formula does here. So that's A2 plus 0.35, now it's A3 plus 0.35, now it's A4 plus 0.35, now it's A5 plus 0.35. So I put a formula in that says, take this number, the one right above this cell, and add this number to it. So when I drag it down, it just keeps going the number above, the cell above, adding 0.35. So it repeats that formula again and again and again, all the way down. And notice our ending point, 3.825, if I went one further, it would be past that 4, that value that we're supposed to go to. Then, this formula already has to take whatever this number is times 7 and add 4, right? So when I drag this down, it's going to fill that same formula, and it's going to keep on going 4 plus 7 times that number, 4 plus 7 times that number, 4 plus 7 times that number. So you drag that formula down. Again, go from that big fat plus sign to this thin plus sign. That means you're in the right spot, and that fills in all those. Then this column is just 0.35. If you drag it down, it'll just stay 0.35 all the way through. And then the area is B2 times C2. Now it's B3 times C3 and all the way down. So notice B2 times C2, that's B3 times C3, B4 times C4, B5 times C5, and so on. All these areas. And notice the answer is over here, 52.5. So again, our template's already there. It already has a formula over here to figure out the sum. Once you get all the boxes filled in, you got the correct sum. So that's the correct answer. So 52.5 is what we get for that one.